thermal energy based electric power station. In this, the turbine is rotated using steam. Water is heated in a boiler using the thermal energy released due to burning of coal. Steam of very high temperature and pressure is generated. Energy in the steam drives the turbine, thus the generator connected to the turbine also rotates and electric energy is produced. The steam is converted back into water and water is recirculated to the boiler. So if you want to draw the flowchart showing the generation of electric energy using thermal energy, first we have fuel coal. In this the chemical energy is stored in coal. And when coal is burnt, heat is produced. So using that heat in the boiler, water is converted into steam. Then that hot and high pressure steam drives the steam turbine, which also rotates the generator, and ultimately electric energy is produced. After the turbine is rotated by the steam, steam is cooled back and is then again converted into water. Again it is given to the boiler. So this cycle, it continues and electric energy is generated. Since thermal energy is used here to generate electric energy, such power plants are called thermal power plant. In the thermal power plant, chemical energy in the coal is converted into electric energy through several steps. So first we have chemical energy of coal. Coal is burnt in air. It reacts with oxygen in the air to produce carbon dioxide and heat. Then that heat is used, that means that thermal energy is used to boil the water. Then we have kinetic energy in the steam, which is used to increase the kinetic energy of the turbine, which is then fed to the generator and ultimately electric energy is formed. So this is the energy transformation in the thermal power plant. So why the energy in the coal is called chemical energy? Because in that the heat is produced through a chemical reaction. Why steam is used to rotate the turbine? Because it is convenient. Means when water is boiled, it expands to a large extent. It has a large capacity to store heat energy. In Science 1 in chapter 5, we have seen the specific heat of water is very high. That means when water is heated and converted into steam, that steam can hold a large amount of energy. And that's why steam is used. This is the schematic of the thermal power plant. So here you can see first the boiler. Here the boiler is shown. So boiler will be used to boil the water. You can see the pipeline over here, and the coal is burnt in the boiler. Large amount of heat is produced and that heat is used to boil the water. Then we have this turbine. So the kinetic energy of the steam, so here steam is flown on the turbine. Kinetic energy of the steam is used to rotate the blades of turbine, which ultimately rotate generator, and then electric energy is produced in the generator. Afterward the steam is given back to the cooling tower. In the cooling tower there is cooled water which condenses the steam back into liquid water, and then that water is again pumped into the boiler. So if you see a thermal power station, you will observe two types of towers there. The first one, it is giving out the smoke and the gases produced in the combustion of the coal. The second tower is cooling tower, and that is giving out the vapor and hot air. So compare the schematic of thermal power station with the block diagram and you will understand where is the boiler, where is the turbine, generator and condenser, how they are arranged one after the other. After combustion of fuel in the boiler, emitted gases are released to atmosphere through very high tower. Once the turbine is rotated using steam at high temperature, high pressure, steam temperature pressure is dropped down, it decreases. The steam is converted back to water by taking out of heat out of it, that is used in the cooling tower, and for that cold water is used. The water in the cooling tower is circulated through the condenser. Heat energy in the steam is given to the water and then steam condenses back to water. Heat absorbed by the water is then released to atmosphere through water vapor and heated air through the cooling tower. Although thermal power generation is a major way of electricity generation today, it suffers from certain problems. Now, what are the problems of the thermal power station? Air pollution due to burning of coal. Coal has nitrogen and sulfur, means it has the traces of nitrogen and sulfur in it. So when coal is burnt, not only carbon dioxide is produced, but along with that oxides of sulfur and nitrogen are also produced, and they are responsible for the acid rain. So they are the polluting gases. In addition to these polluting gases, three types of polluting gases we have seen, that carbon dioxide, sulfur dioxide, nitrogen oxide. Along with that, the smoke also comes out, that means the unburnt coal particles, soot particle, as we have seen, the black soot particles are also released, and they are also polluting the environment. They can cause serious health problem of the respiratory system. The reserves of the fuel used in this method are limited. Coal is limited, and millions of years were used for the production of coal. When the trees are buried deep down the earth and then heat and pressure works on it for millions of years, then only coal is formed. So in next few hundred years, all the coal storages will be wiped out, will be finished. So we have to look for the alternate to that. But at present, the major part of electricity in India is produced by such thermal power station. Vindhyanagar in Madhya Pradesh, 4760 megawatt. Mundra in Gujarat, 4620 and 4000 megawatt. In Tamnar, Chhattisgarh, 3400 megawatt, and in Chandrapur, Maharashtra, 3340 megawatt.